While nitrogen emissions are known to have a cooling effect, scientists caution against considering it as a viable solution for addressing climate change. Greetings, everyone. Today, we are going to delve into a fascinating subject. Researchers have made an intriguing discovery. Human-generated nitrogen emissions actually have a cooling impact on the climate, countering some of the effects of global warming. However, it is important to approach the idea of increasing atmospheric nitrogen as a climate solution with caution, as it can have detrimental effects on health, biodiversity, and the ozone layer. While nitrogen does play a role in mitigating overall warming, it is not a comprehensive solution when compared to the reduction of greenhouse gas emissions. Therefore, it is imperative that we gain a comprehensive understanding of the intricate interactions involving nitrogen emissions in order to effectively address the urgent issue of climate change. Now, without any further delay, let us embark on our discussion. Today's publication in Nature reveals a fascinating discovery. The release of reactive nitrogen into the environment as a result of human activities actually has a cooling effect on the climate, reducing it by approximately minus 0.34 watts per square meter. It is important to note, however, that while this cooling effect is significant, it does not counterbalance the warming impact caused by greenhouse gases in the atmosphere. Without the contribution of human-generated nitrogen, global warming would have progressed even further. Authors from the University of Sydney collaborated with the Max Planck Institute in Germany to lead the research paper. This significant study coincides with the release of data from the European Union's Copernicus Climate Change Service, which revealed that Sunday, the 21st of July, marked the highest recorded temperature in recent memory. There are four distinct ways in which the cooling effect is manifested. The atmosphere is polluted by the formation of fine suspended particles caused by the combustion of fossil fuels, which in turn shield sunlight and contribute to the cooling of the climate. The release of ammonia, a compound containing nitrogen and hydrogen, into the atmosphere due to the use of manure and artificial fertilizers produces a comparable impact. The application of nitrogen to crops enhances their growth, leading to increased absorption of CO2 from the atmosphere, thereby facilitating a cooling effect. The breakdown of atmospheric methane, a powerful greenhouse gas, is also influenced by nitrogen oxides. The researchers cautioned against relying on the increase of atmospheric nitrogen as a viable solution to address the challenges posed by climate change. Professor Federico Maggi from the School of Civil Engineering at the University of Sydney firmly asserts that the pollution of water by nitrogen fertilizers and the contamination of air by nitrogen oxides from fossil fuels are undeniable facts. As a result, he categorically states that elevating nitrogen levels in the atmosphere as a means to address climate change is not a viable middle ground nor a genuine resolution. According to Sönke Zähli of the Max Planck Institute, while this may initially appear as positive news, it is crucial to consider the detrimental impacts of nitrogen emissions on various aspects such as health, biodiversity, and the ozone layer. It is essential not to overlook these harmful effects or view increased nitrogen input as a solution to address global warming. The majority of the air is composed of elemental nitrogen, accounting for approximately 78%. This particular type of nitrogen has no impact on the climate. However, various reactive nitrogen compounds can directly or indirectly influence the global climate, leading to either warming or cooling effects. Nitrous oxide, N2O, for instance, is an extremely potent greenhouse gas with a potency nearly 300 times greater than that of CO2. Additionally, different nitrogen forms contribute to the creation of ozone in the troposphere, a powerful greenhouse gas that intensifies global warming. According to Professor Maggi, the research holds significance in providing the team with valuable insights into the overall impact of nitrogen emissions from agricultural activities. He stated that this piece of work serves as an exceptional illustration of the inability of simplistic evaluation tools to comprehend intricate interactions on a planetary level. It highlights the significance of constructing mathematical models capable of demonstrating the occurrence of non-linear or disproportionate impacts encompassing soil, land, and atmosphere. While it may seem contradictory, the introduction of reactive nitrogen into the environment, primarily through agricultural fertilizers, can actually contribute to a decrease in overall warming. Nevertheless, this effect is relatively insignificant when compared to the substantial reduction in greenhouse gas emissions that is necessary to ensure the planet remains within safe and sustainable limits. The emergence of advanced computational tools for the new generation has significantly contributed to the advancement of knowledge in the field of climate change science. However, it is crucial to acknowledge that mere understanding is insufficient. Urgent action is required to effectively mitigate greenhouse gas emissions, developing a comprehensive comprehension of the effects of nitrogen in its entirety. In order to assess the total influence of nitrogen originating from human activities, the scientists began their analysis by examining the quantities of different nitrogen compounds that ultimately find their way into soil, water, and air. The researchers inputted this information into models that illustrate the worldwide nitrogen cycle and its impact on the carbon cycle, such as the promotion of plant growth and the subsequent levels of CO2 and methane in the atmosphere. Using the outcomes of these simulations, they employed an additional atmospheric chemistry model to determine the influence of human-generated nitrogen emissions on radiative forcing, which measures the amount of radiant energy that reaches 1 square meter of the Earth's surface per unit of time. To support our channel's growth and ensure broader awareness, kindly hit the like, share, and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance. To support our channel's growth and